right. Welcome, everyone, to another exciting episode of Anterix's Industry Insight webinar series. I'm Mike Brozek, VP of Customer Success with Anterix. I'm honored to be your host today. We've got a great topic and a fantastic panel to bring the insights and innovation you're seeking. Utilities are deploying private broadband wireless networks across the nation, and those efforts are being completed to support use cases such as grid modernization and some newer use cases like wildfire mitigation and distributed energy resource management. Today's topic is centered around deployment best practices and realizing business value ahead of schedule. There are three key takeaways that I want you to consider from this webinar. If you walk away with nothing else, I want you to remember these three. First off, network resiliency requires careful planning, deployment, and operation. It doesn't happen by chance, and it can be difficult to retrofit networks once they're built. I like to say, plan it right, build it right, and run it right. Number two, there are tools, processes, and solutions that are available for utilities to accelerate device deployment and reach true business value sooner. Anterix's active ecosystem, which many of our panelists are part of, has over 110 companies ready to help utilities deploy these networks. And number three, and probably one of the most important, security is one of the greatest benefits of a private network. It must be considered throughout the entire process, and additional layers of security can be added when necessary. So with that, let's get started. I'd like the panelists to introduce themselves, and we'll start with Gautam.
Yeah. Hey, Mike. Thanks for the opportunity. Gautam Talagery, I'm with Ericsson. I'm part of a team that's responsible for solutions in utilities, and we have deployed a few networks already in the US, and I very much look forward to sharing lessons learned and insights from what we have learned in deploying LTE.
Thank you, Gautam. Ken?
Thanks, Mike. My name is Ken Rosenberg. I'm a Director of Product Management here at Anterix in our Product and Innovation team. I'm focused on our SIM management and solutions and services, and it's a pleasure to join this panel today and speak to you.
Thanks, Ken. Jose?
Hey, this is Jose Nieto. Hey, thanks for having me. Very excited to be here with you all. We are part of the solution sales team where we help our customers to find the right solution regarding implementation of SIM cards, eSIM, and the appropriate platforms for remote management, either if it's for SIM, device management, or eSIM itself, right? So the good thing is that we work with all type of partners and players in the ecosystem, either if it's a tier one MNO, if it's a OEM, if it's a private entity, so we can have the learnings for the multiple sectors and give the best solution for their utility customers. So really happy to be here with you and share all the learnings we have had.
All right, thanks, Jose. Scott?
Yeah, hi, I'm Scott Burk with Advantech. I'm a vertical sales specialist in the energy markets. Advantech's a hardware manufacturer. We're building products for communications and connectivity for the last 40 years. Today, we have over 1/3 of the market share for IPC, for edge compute. We've deployed over 1 million wireless routers, so we do understand critical communications, what it takes to build a resilient network. So I'm looking forward to this panel discussion today. Thank you.
All right, great. Well, let's dive into the topics and the questions here. As I mentioned before, utilities across the nation are deploying private broadband networks as we speak. And we're going to start with Gautam. And Gautam, what are some of the challenges that you're seeing out there utilities are facing? How are they overcoming those challenges? And more importantly, what are the lessons learned for those utilities that will come in the near future?
Yeah, thanks, Mike. Yes, when we deploy LTE networks for utilities, it's all about establishing connections from an end-to-end perspective, going from the device all the way to the utilities applications. A couple of challenges, operational challenges here. SIMs have to be procured in volumes that probably start small and then rapidly grow. Once you've got those SIMs in place, then you've got to start synchronizing subscriber profiles and characteristics, authentication vectors, from the device all the way through the network to the application. So that's something that needs to be addressed. And all this falls under integrating the security aspects of wireless into an existing OT infrastructure. And bringing that together requires a process, a network-wide process across all the different stakeholders. Many of us represented on this panel here. We got to work together and acquire the SIMs, program the devices, activate the connections, and then do the lifecycle management for all these SIM connections. And as a part of that, as you deployed networks, some of the lessons we have learned and some of the insights you derived from the industry are that the successful deployments usually start small. They have a focus. The purpose of PLT, of course, is multi-purpose, bringing multiple networks together. But when a successful network starts small with a certain focus, and that focus then addresses many of these operational challenges, establishes an internal process, and then having done this, that success then feeds into quick growth because the business then understands that private LTE is viable, feasible for grid modernization. Resiliency and is also a very important aspect to this. Usually you start with local redundancy, so your single data center is all set for local failures, and then you build geo-redundancy across centers. So now you have a truly geo-redundant mission critical network. Then the last part of this is, sorry.
Go ahead, Gautam.
Yeah. And then the last bit was about the use cases. Picking the right use cases so that you're able to port from the existing infrastructure to wireless, considering all the intricacies of latencies and timings within the devices. So those are some of the points here.
Oh, great. Thanks, Gautam. Ken, let's dig into this SIM issue.
Sure. Thanks, Mike. Yeah, so I mean, one of the things that our customers are struggling with is the journey to get SIMs into devices in a timely manner, and that seems to have really bubbled up. We've had some utilities through our utility strategic advisory board share with us that it took them 11 months to get SIMs for their devices. But when you actually peel back the onion on this and speak to some of the critical parties in the supply chain, there's a real opportunity to improve upon this, because it's, what's happening here is it's a combination of building domain expertise within the utility. I mean, these are new muscles that they're learning. They don't come at this with an expertise in private wireless, and they're building that. And it's also a combination of more of a committed focus from the ecosystem of vendors to realize that utilities are not like mobile network operators. They have use cases that are very different and need specialized support to help them be successful.
Great. Thanks, Ken. Jose, you represent G&D, one of the largest SIM providers in the world. Can you add on to Ken's points?
Yeah, definitely. So when we're thinking about the personal challenges and how to start putting the building blocks together, definitely setting the SIM piece and the deployment and how to start with something that can get us going is where we have seen some of the struggles. And of course, it needs to be understood by the industry that we need to develop something where we can abstract the complexity of the SIM, have something generic that can take us off. And it doesn't mean that it will be set in stone forever in that device, right? We know that we can rely on remote management technologies to update those SIM cards or files or even profiles over the air once we see that the network is evolving and is growing and is getting more resilience and use cases. So I think that's one of the main learnings that we have had is how to make things simple, get things started, and then allowed to grow as we go, right? And that's the model that we are trying to implement, that cookie cutter approach. We can get going, and then of course at the same time trying to help as much as possible consult to our utilities customer to make this journey as quicker as possible.
Great. You know, in a previous conversation we had, you said something that I think I could add to my list of takeaways. You said the SIM is not simple. Can you elaborate on that a little bit more?
Yeah, definitely. So at the end of the day, we see the SIM, we take it for granted, but in reality, it's a computer in a small chip, right? So it has an OS, it has files, it has application, but all in a simplified bit by bit scenario that you need to control very carefully, right? So we understand it's complex for new players in the environment, and that's our main job, right? How to extract that complexity and allow them to run it based on the main business decision, right?
Great. All right, Scott, same question to you.
From lessons learned, I would say, the big part is training of the workforce. The RF planning comes into play, understanding, once stuff is going to go into the field, the kind of coverage, and with that, what types of antennas to use for the best signal reception, how far away are we from the towers, and then obviously with the SIMs, hey, am I looking, do I need 2 SIMs into this box? Is it 1? That's always key, but I think there's a lot of groundwork that has to happen to make a real easy deployment. There's a lot of work that goes into the interoperability, the integration of the lab, but also understanding what they're going to be connecting to. What are the physical requirements? Nothing worse than getting out there with wireless routers that have RJ45 interfaces, but the cables that are still out there are using RS-232. So you want to be aware of that, right? Last thing you want to do is multiple truck rolls. So a little bit of pre-planning to understand what you're connecting to.
That's great. All right, so we really covered, my first 2 of plan it right and build it right. Gautam talked about some of the redundancies that can be built into geo-redundant cores, redundant connections to tower sites, those sorts of things. Let's move into the run it right section. Gautam, I'm going to start with you because you've got quite a bit of experience with operating these networks. So we planned it right, we built it right. How do we run it right?
Yeah, building it right is making sure that you have a resilient network, and having that resilience in the network would be both at a hardware and the software level. So when you have an architecture that's usually a container-based architecture, has redundant software processes and redundant hardware, so that there really is, you minimize your single points of failure or eliminated them. You also need reliability in the device to handle the environmental setup in the actual field. Subscriber and session data is something which can easily which needs to be taken care of in synchronizing between different locations, so that if you have a data center failure, you don't affect mission critical traffic. And usually how that's done is you have OSS BSS solutions that spin up redundant network functions if one of them goes down for some reason. So being ready to quickly heal in case of a failure is important. And then finally, of course, having a fallback network, because end of the day, the RAN site always continues to be one place where things can go wrong. And if that RAN site on the private network was to have a problem, then having the device to automatically fall back to a different network is something which both the device and the networks have to be capable of. And we can discuss about that as we go further into the panel.
Thanks, Gautam. Ken, let's dig into that a little bit more. Gautam was talking about using another network that's out there. And I think that we get back to the non-simple SIM being able or being set up correctly for that. Talk to us about failover and how that can increase resiliency for these networks.
Yeah, thanks, Mike. So, one of the things that Gautam really hit on was using diverse routing paths, in your network design and topology. And one of those diversity of routing paths is the fallback to essentially the public network from the private network, and to have that set up with potentially as many public network options as possible. So you build in multiple levels of redundancy, for resiliency purposes. And from on configuring that through a SIM, there's multiple ways to handle that. You can actually configure mobile network operators subscriptions directly on the SIM and the SIM profiles. You can have them set up that way, or you can adopt an approach that uses a single IMSI, sort of a donated IMSI range from perhaps a mobile network operator that automatically has the programming, in the SIM profile, such that it prioritizes the private LTE network first, and then should there be a failure in the private LTE network, it immediately looks for, based on algorithms that are in 3GPP, it looks for the public cellular networks.
Very interesting. So what you're saying is that utilities would not have to go out and negotiate roaming agreements on their own. Am I reading that right?
That's correct. I mean, they certainly can, but if they choose to work with a single provider, a lot of those can be arranged ahead of time and have multiple different options available to them in that package.
Yeah, definitely sounds like a big time saver. Jose, you guys provide SIMs all over the world. How do these arrangements work? How can I get a SIM that I know is going to work on another network?
Yeah, definitely. This is a great question. And at the end of the day, we need to be very flexible, because depending on how your customers have their contract with the certain service provider, they could negotiate their own agreements, or they might need to work with partners to handle this. So at the end of the day, we need to be agnostic and be flexible. And by design, bring this resilience to the SIM card as much as possible. There are many ways to do it. It could be based on multi-profile approach, could be virtualized in different network profiles. So we need to enhance the SIM card to be autonomous, because network interruptions are normal. They happen all the time. Of course, we will try to reduce it as much as possible, but if it happens, it needs to have enough autonomy to know when to switch to a different network, to fall back, or even receive a remote instruction to use a new network as default, because you might have new network evolution and things change over time. So this is one of the technologies that I think is key to bring into this ecosystem, because it's a growing environment, and we don't know what is going to be available in 1 year and 2 years from now, but we know we need to have an approach that allows us to get there without going and replacing all the physical assets that are already deployed on the grid, right?
Yeah, Jose, I'm thinking of a term that I've heard before called over-the-air programming. And I think that's what you're talking about, right? Avoiding that truck roll, making sure that you're set up correctly. So if you need to make changes to that SIM, you can do that over the air. Can you explore that a little bit more for me?
Yeah, definitely. So at the end of the day, we see it as an insurance. They have the capabilities to do changes when you need it, because down the road there might be changes in business decision, it could be issues, and you always want to have the capability to remediate that situation without physically going to that device, switching the SIM card, or replacing that. So thanks to the OTA specs that have been out there in the market for a long time, we can rely on those as an insurance mechanism to get control of all of these assets over the air and most importantly, in a secure manner, right?
Thank you. So Scott, we've talked about Cord and RAN, we've talked about getting the non-simple SIM set up correctly. Now we're finally at the endpoints. How to run the network right in your mind from the endpoint perspective?
Yeah, from the endpoint, I think a lot of that comes into play with the device management of these endpoints, the gateways, the routers that you need. You need a device management platform that's going to protect the database, do the digital twin, so that it has an image, the golden image, quote unquote, that utilities will standardize for that device. you want to have the keys in the control center. You know, you want to preserve that. You want to be able to do ease of installation, right? The zero touch and the zero trust, which we'll talk more, I know, about. But you want to be able to control the rollout. You want to control the upgrades. You want to be able to do mask configurations. You want to control what devices come into the network. You want to make sure that nobody can make changes to the network. So having a flexible device management platform with a lot of tools will certainly make that a lot easier to roll out. And then having the integration into the utilities back office, you know, what you're going to do with that data that you've collected now and how you control it through your SCADA environment.
Great. Thanks, Scott. Let's switch topics just a little bit and let's talk about onboarding of devices, because if there's one thing we know, once these networks, as they're being built, more and more devices are being brought online. And in the same order, we'll start with Gautam and I want you to kind of speak to, you know, the ability to tie systems together to try and make this onboarding process as close to zero touch as we can. Can you talk about that?
Yeah, sure. This, you know, as I mentioned initially, this is really a village is needed to build a very successful private LTE network. There are a lot of stakeholders in the SIM manufacturers, the devices, the networks. We've got to establish the right process flow between the SIM, the device, and the network partners to ensure that the onboarding process is something that we, you know, we hand the baton from one to another. The first set of SIMs have to be acquired through the supply chain. We've got to run through the process of onboarding it with the right parameters on both the SIM and the network. And once that the initial set of SIMs have been successfully integrated into the network, that's when there might be some lab activity to understand that the device that you're onboarded is meeting the requirements you have from a performance perspective, as in switching between networks, having the right security parameters, and protected from break-ins. And then comes automation part of it, where we get into building the automation of bulk provisioning of a SIM into a network, activating them in volumes, avoiding the truck rolls that was mentioned before. So the onboarding process is really a process of all of us working together in our respective parts and ensuring that the data flow between us is synchronized and well documented.
Great, thanks, Gautam. Ken, again, going in the same order here. You know, Gautam uses this term, it takes a village, and it certainly does. Let's talk about the benefits of a SIM management system with, I think the term is API into the Gautam's core system or other providers. Can you talk more about the importance of APIs?
Sure. You know, so as Gautam mentioned, the SIM is essentially, you know, that's that digital passport to get the device onto onto the network. And in order to do that, you know, if you have a SIM provisioning system, that system needs to be closely integrated to, you know, the private core. So in Gautam's case, that's an Ericsson core, and in order to make that integration smooth, you need well-documented APIs that, you know, on both sides, on the core side and on the, you know, the SIM management provisioning system side, that can seamlessly make those transactions, you know, in a click of a button. In addition to that, with utilities and you know, other folks in the space, there may be needs to leverage APIs for utility asset tracking purposes. They may have, you know, systems, northbound systems that also want to pull on the SIM management portion of the solution. And that is all orchestrated through secure, you know, universal APIs.
Great. Jose, can you talk a little bit more about the capabilities that are out there today, where APIs are able to integrate all of these systems so we can get these devices on the network faster?
Yeah, definitely. So that's a key component to really get to the zero-touch provisioning and automation that we are all looking for. It all starts with identifying the right triggers, right? It all starts with the right trigger. It's either deploying the fleet of devices, identifying once the device is powered up as soon as possible, so we can feed the systems and do and piggyback on these API integrations to complete all of these flows, right? So from the SIM management perspective, there are certain tools and capabilities where we can have this trigger enabled to know exactly when a SIM card needs to be deployed, when it has been turned on, to detect that, and then they identify, hey, what is the most current business logic that needs to be applied to this SIM card or to this device? Is it current with the latest objectives? And then trigger those updates as a customer need to. Not only during provisioning, but also during the life cycle of the device, right? Knows how the SIM is going, how the network KPIs is being reported, and identify when is the right timing to do a correction if needed.
Great, thanks, Jose. Scott, I used a term and probably didn't do a good job of explaining it, but I hear about this thing called zero touch. From the endpoint device, what type of automated processes do you have to help achieve this? Maybe start with, what is zero touch?
Yeah. So zero touch is the idea that a router or gateway is going to be preloaded with the IP address of the management platform that's being controlled by the utility in their control center, right? So at the factory, it's preloaded with this IP address. When it's installed in the field, the idea is that the technician's not having to get out a laptop, plug into it, call back, try to get IP addresses, set up VPN. So as soon as they hit power, the device boots up, it registers, it looks, and it's basically dialing home. And it sees this one IP address, that's all it can communicate. And at that time, when it identifies itself to the host authenticates it. There might be a security certificate exchange between the devices to authenticate it into the network. And at that time, the database is pushed down to the router or gateway so that no provisioning is done in the field. It comes up with the image that was already preloaded back at the device management platform. So you can also add some other steps for security in that as well.
Great. Well, you perfect segue, because security is our next topic, and we talked about this being one of our key takeaways from today. So again, one last loop around in this order anyway. Gautam, let's start with you. There's a lot of security built into the LTE, global standard, but what are you seeing that utilities are doing out there as these deployments are occurring specific to securing these networks?
It's definitely something that keeps a lot of the utility stakeholders up at night, because it's a mission critical network, and breaking in is definitely not something that's nice. A couple of different areas. The device, of course, has to have security built in, and from a network perspective, having encryption for the data which is at rest and in transit from the device to the network is paramount. Strong authentication mechanisms are needed, which are derived from 3GPP. We got some pretty good protocols in there which are applicable to us and which can be implemented. The part that makes it a little more secure is when you have segmentation of traffic. So the way by which you provision and manage a device should be on a different network segment than regular traffic. So that way, by chance, if someone does if you get a man in the middle while you're trying to configure a device, the network is not compromised. From a network perspective, it's important that we have intrusion detection and prevention systems, a security manager that's pulling information from different nodes across the board from device, from network, from applications, calling out the abnormal behavior and alerting security incidents, being proactive about it. Those are some of the security measures that come in. From an operational efficiency perspective on how you can, get security to play with operational efficiency, it's all about standardization. The more you standardize devices, the more that you've been on the journey before and you're able to get more efficient with your operations. Management and automation comes in there. And of course, when it comes to balancing the two, that's where the security folks need to be collaborating more with the operations folks, so that the operations folks are aware that there are certain security protocols that are needed, whereas and vice versa. And so wireless performance metrics, which are tied to security, is also another important part. But it comes down to collaboration to get the right balance between security and operational efficiency.
Thanks, Gautam. Ken, let's talk a little bit more about security as it relates to SIMs and profiles and management. It sounds like it's really important.
It is. We're certainly going to touch on this in a little bit as well, but I just wanted to pick up where Gautam left off with respect to, standardization, and that's the piece I think that's really important. So wherever possible, with respect to SIMs, we would advise taking the time to arrive at one or more standardized SIM profile templates that have some of these pre-configured security aspects in them that are essentially built in. This will reduce the time and effort needed to configure devices securely once it's time to activate them on the network. And then, with the systems that are in place today, like SIM management systems and things of that nature, accessing these through role-based, authentications, and potentially single sign-on throughout the utility network, such that this reduces the management burden of having multiple credentials to access the system, and then just allowing users of these systems to speed up access while maintaining security.
Jose, I want to dig in a little bit more. The SIM card has these encryption keys in it, and that's extremely important. Can you talk about, because G&D, you guys are the ones burning these, what type of security requirements are in place? What type of regulatory certifications are required to be able to do what you guys do?
Yeah, I think this is a great question, and this is the core value that any SIM vendor can provide, right? Bringing the root of trust components, because the SIM is the key to the network, right? So it has the right credentials to be authenticated, to get use of the service, and to ask for certain services to be enabled. So of course, it's key to have an implementation that is fully compliant with the specs, that applies all the legacy 3GPP, ETSI standards, how to handle all SMS, HTTP communication, because that's the most important part to start using the services, right? So of course, there are certain certifications in place on how to even generate that data that is going to be placed on the SIM cards and needs to be authenticated with the network. All of those person needs to be certified. How do we store the information needs to be certified. What type of mechanisms we are going to use for encryption, if it's software-based or hardware-based. And of course, we all know that hardware-based security mechanisms are the more secure. And that's what actually the SIM card does, right? It does a calculation based on certain pre-shared keys that only the core network will know, right? And after the fact, also when we need to reach out to the card and do any changes, we will have a specific set of keys and counters that will allow us to remotely manage those assets. So we really prevent and make sure that no one else is being able to push any changes down to this, right?
Great, thanks, Jose. Scott, again, from the endpoint perspective, what are some of the security solutions being deployed out at the edge?
Yeah, there's quite a few things that can be done with the end devices. You know, the first is working with the utility, getting the SIMs sent to the factory where we marry the SIM with the IMEI, the radio module on the device itself, that information, so that nobody can take a physical SIM out of a device and go pop it into somebody else's device and come up in the network. You can tie it down that way. You can do security on all the unused ports on a device, locking them down. You can tie the CPE that's attached to the wireless router gateway down, locking down its MAC address. So there's some things that can be done. In addition, you can start running an app security on the CPE as it transmits through the gateway that's already, working with the 3GPP standard, the SIM, talking to the network, but you can also now, with the router, doing a VPN and AES encryption back to your core server. So there's quite a bit of security that can be implemented on the end devices themselves.
That's great. Okay, so we're going to shift gears here a little bit, and I've got a specific question for each of the panelists. Instead of us all answering the same question, we're going to have a specific question for each one. Ken, I'm going to start with you. I hear about this thing called eSIM. It reminds me of like flying cars. They've been promised since I was a kid. I used to read Popular Mechanics. They're still not here. When do I get an eSIM? What is it, and why is it better?
Mike, I actually think that Jose would probably be the best one to answer things directly about the eSIM right off the bat, and I'll add some commentary to Jose's topic around the evolution of the eSIM technology, because he's a resident expert here on the call around the cards.
Jose, you have the ball.
Yeah, it's a great question, and I think that when we mention eSIM, it's a very broad term, because at the end of the day, there are multiple specs. There are different devices that they may support this technology, either if it's the spec for the consumer devices or for IoT and M2M devices that are working completely different standardizations. So GSMA has different definitions for each, because it all depends on how the business model will be, who is going to push for the profile, who has control of what profile is going to be used by the device, right? So at the end of the day, this is something that it will provide, as I previously mentioned, is an insurance to know what is the best suitable network for that device to use at certain point in time, right? So we start with this crawl, walk, run approach, where we start with a reliable network that will get us off the ground. But in the future, if there are issues or there are a new configuration that needs to be done, we can just download a virtual profile over there or send the instruction to the SIM card to switch to that profile that we are intending to, right? So those are the benefits that is bringing. And of course, as part of the evolution, it needs to adapt to these specific use cases, because legacy implementations in M2M and IoT relies heavily on the use of SMS to trigger and wake up some of the devices out there. And we know that in private networks, not all the time we will have these beaters in place. So the specs are evolving to only use IP-based communication, and then also let the device makers and the device managers to know the best that they can with the devices to trigger up operations, but make all the eSIM management activities as optimum as possible and secure as possible. So the specs are also evolving, and as these new standards are in place, of course, we will be the first one seeing how to implement and how to help the utilities.
Great.
So,
anything to add?
Yeah, so I was just gonna mention, Jose, not everybody on the call may understand what an eSIM is, right? So I think it's the evolution, and the evolution of SIMs, right? I mean, I think most of us understand, what the legacy SIMs look like. They're, little plastic items, right? That have the operating system on it. Kind of looks like, in the middle of it, looks like a credit card, But the industry is now moving to the eSIM, which can be a solderable item that actually lives on the board of a device. right? So it's no longer, so from a logistics perspective, it's one less thing that one less physical thing that the utility would need to track as the industry moves more towards the use of eSIMs. And then of course, what Jose was referencing is that the eSIM technology, the EUICC, is something that can be updated over the air, remotely through an RSP service or with the SIM OTA service that that a lot of folks are now using. And then the evolution of the card itself is now even moving towards an integrated SIM, where the actual it's no longer a soldable component. It's just an operating system that gets downloaded on the actual say Sequans or Qualcomm chip that's running in the device. So those are the things I wanted to add to Jose's.
Great, thanks again. Hey, while I've got you, we've been talking a lot about SIMs, SIM management. What are the key factors to consider when you're looking at SIM profile management solutions?
Okay. So as I mentioned, the SIM profile is really analogous to a digital passport. It specifies how a device connects to the network or network it operates on. But it's not just the network you have to think about. It's also the use cases for those devices. Will these devices primarily be always on and always connected to power, or will they operate on battery? Because those are two different types of use cases, and the way you configure the SIMs for those devices would be different. And Anterix, we like to envision kind of a three-legged stool when thinking about the SIM profile. And if any leg of that stool is not optimized properly, the device is not likely to have the best user experience on the network. And so the legs of that stool are the EUICC profile. That's the digital identity of the card, and how it interacts with the network. Think PLM identities, authentication elements for the card itself. The HSS profile as it pertains to the SIM, that contains user-related access and service-related information. And then APN profiles that define the settings for secure, reliable, and efficient data connection between the device and the packet data network. And I think it's important to understand that there's always going to be an element of customization of the SIM profile for each utility. But in Anterix, we feel we're in a unique position to help our utility customers standardize on a common set of settings that can be made industry-wide based on a common set of these utility use cases. And this would help streamline the profile development and the onboarding of these devices dramatically for our customers and allow them to get their devices on their network much, much faster.
Great. I'm going to go to you, Scott. Edge devices, edge computing. Gosh, your world has changed so much in such a short period of time. Talk a little bit about what the capabilities are of these smart edge devices, and what are some of the use cases or solutions that you're seeing utilities deploy with these new capabilities?
Yeah, I mean, we are seeing a change. It's starting to happen. I mean, for the longest time, right? We put devices in the field, and they would just connect. They were acting like a bit pipe. What data came into the device had to go back to the control center. We're starting to see more of a demand now for edge compute, and it's a slow adoption, but it is happening. We're seeing it with DER gateways. They need to start doing electrical fingerprinting, determining and understanding what's driving demand, how to control power, not just in one direction, but bi-directional usage. We're looking at microgrid with edge processing to be more efficient. We're looking at obviously peak shaving in conjunction with battery energy storage, but then we start collecting data for that footprinting and demand, and understanding how to do load shedding even more so. But there's all these things now that are driving, and we're seeing it from Advantech. We see it at the substation with the utilities, looking at virtualization and leapfrogging later into edge compute with AI to do predictive maintenance. And that's going to push further into the very edge itself. We'll see more and more predictive maintenance starting to be rolled out into the field to be more responsive.
Wow, there's a lot of changes happening and even more done, for sure. Okay, Gautam, close up this round with you. You mentioned before some things that, and I want to dig into resiliency a little bit more here. You talked about geo-redundant cores. We talked about multiple backhauls to RAN sites, that sort of thing. Now, I'm probably going to date myself a little bit here, but I remember the old days of redundant servers, and we had these terms we would use like active, passive, and it helped me understand if I'm running 2 cores that are in 2 different data centers, and I've got 2 connections to every RAN site. How does that work?
It's through the pooling of resources at a network level. So when your base station is connected to both the data centers through a pool that has a primary priority at your primary data center, and if that data center goes down, then because the base station is connected physically to both the sites, logically to both the sites, the pool then ensures that traffic switches to the other one. So that is an active standby from a base station perspective, where both data centers are active, but only one is really serving the traffic.
Okay, now that makes a lot of sense. Thank you. While I've got you, what are some of the primary challenges utilities are facing as they are trying to ensure their networks are going to be more resilient? And while we're there, do you have a definition for resiliency when it comes to private networks?
Yeah, that's an interesting question. Yes, a private network would be a network that's protected from the bursts of traffic that you would get from a normal set of subscribers. It's also got its own PLMN, so that it's identified to be distinct from other traffic. And because it's private and because it's focused on a certain closed group of devices, it allows the utility to be more precise in the way that they manage the network, upgrade it, have the right features, and they're not dependent on a smartphone-driven network to be dictating their strategy. That really is the value and the difference, I guess, in a private network. And your other question was on challenges. And when it comes to challenges, I think the process flow of programming a SIM and a network independently with the right parameters and having a mechanism to activate that SIM on demand is one of the challenges that's out there. How do you get to an assembly line process where you want to establish a connection in the network, you go out there, you get your SIM, you provision it, you set it up, and it's ready to connect. That whole cycle is a challenge. Another challenge which is involved in integrating devices to networks is more the logical one of not having coverage. So RF conditions at the locations of devices is something that needs to be better understood, because the antennas tied to the devices and the height at which these devices are mounted can make quite a difference in performance. So addressing both those are 2 challenges which need to be addressed quickly.
Okay, great. Well, we've got about 10 minutes left, and I've done a lot of talking, so I'm going to stop that. We're going to go in the same order, but I'd like some parting shots, but more specifically, what was something that maybe you wanted to discuss that we just didn't get to, and give you each about 2.5 minutes to delve into that. So we'll start with Jose.
Yeah, so I think that this is a very great time to discuss about what is the real struggles that we are facing, that we are meeting, and identifying the areas of opportunity to really streamline the processes. So this session has been great to really identify those areas and see how we can partner together to close those gaps. Because at the end of the day, we need to make a journey that is simple, to onboard, to start, and then have the right mechanisms in place to adjust as we go, right? So I really think for this session, it has been enlightful and hopefully has been for our audience, so we can identify how to move forward.
Great. Ken, over to you.
Yeah, I was just going to speak to some of the key factors to consider when selecting a SIM management solution, Mike. I would say in particular, making sure there's remote SIM provisioning capabilities within that solution to eliminate the need to actually physically touch SIMs once they're deployed and out there. The second, key factor is proven integrations with many of the leading infrastructure vendors, like Ericsson. Gautam's representing Ericsson here, and the APIs that can be used to interface to other, utility asset tracking systems. Not immediately, but certainly in the future. There's a SIM OTA service that gives the utilities the ability to remotely change specific parameters or applets on their SIM fleet remotely. This service obviously becomes more critical the more complex the network gets over time and more devices are on the network. The ability to have private to public failover roaming, essentially built-in resiliency within the solution through direct access to as many mobile networks as possible. And then the last one, really, but certainly not the least, is a key factor is work with a market leader with best-in-class technology that's actively shaping the evolution of the GSMA standards. This is a constantly evolving space, and there's a lot of innovation happening. And so you want to future-proof yourself by selecting, a vendor that's at the forefront of that innovation. So that's it. Thanks for doing a great job of moderating us today, Mike.
No, thanks. Scott, over to you. What did we not cover that you wanted to cover? What are some parting shots?
Yeah, I think, from a manufacturer's point, with the end customers and looking at these solutions to build out a resilient network, you got to look also at the manufacturer themselves, and you want to make sure that you have the capabilities, they have the capabilities to manufacture not just in one location, but in multiple locations. You want them to have the ability to have multiple supply chains. We learned that lesson the hard way a couple of years ago. Everybody relying on one source. You have to have multiple sources. And with that, you have to plan. You have to build a product that is going to go into the utilities network for not just 1 year, 5 years, more than 10. We know that. So then you have to deal with key components that have, long life cycles. Like when we do a lot of edge computing, we see a lot of our competitors are going in there with CPUs that are gaming CPUs. They don't have a long life cycle, so they're, you have to be aware of these kind of things, especially as you look at edge computing. So, having a diverse network, you want to have a diverse supplier as well.
Great. Okay, Gautam, bring us home.
Yeah. Well, we are discussing the integration of a new type of network, a private LTE wireless network into an existing infrastructure. There is a lot to just that action, that activity. There are certain intricacies of a private wireless network which are best handled by, the team of us who are building the wireless network, and then there's the existing IT and OT. So addressing the data which comes from a wireless network and processing it with rules that are specific to wireless, and rules, what I mean is security rules and also data handling aspects. So we got to get that together and then establish an interface of moving that data into the existing infrastructure. And when we are successful with that, then we have successfully integrated wireless into an existing infrastructure. So building a mechanism for doing well in the wireless domain and then integrating that into the existing infrastructure is something which we need to put our heads together on and help in moving the industry towards a wireless grid modernization.
Fantastic. Well, I want to thank all of our panelists today for all of your insights and support. Again, we'll go over the key takeaways again. Like we said earlier on, network resiliency, it takes careful planning. You got to plan it, build it, and run it right on all done. And retrofit is very difficult, if even possible. So it really needs to be done correctly. There are tools, processes, and solutions that are available. The Anterix Active Ecosystem has over 110 members, several of them here today joining us, and their solutions are out there so that utilities can reach that business value that they are seeking for these networks that they're planning to deploy. And then, of course, security. It's got to be from the very beginning and considered all the way through. So those are our three key takeaways, along with SIM. It's not simple. I love that. And I'll thank everybody, and we will close it up. Thank you.
Thank you.
Thank you all.
Thanks,
Thank you,
everyone.
everybody.